Alright, we're going to move on to section 9.3, an arithmetic series. So we did sequences already, when something goes up by the same amount in an arithmetic sequence and we can find any term. An arithmetic series is very similar, the wording is slightly different and the way it's written is slightly different. And a series is just when you add all those terms together. So when terms in a sequence are added, a series is formed. Okay, now the word that they generally use is the sum of. So if they ask for the sum of the following terms, you're looking at a series. So for example, when it's written like this, it's a sequence. 3, 6, 9, 12. When there's a plus in between them, it's a series, and they're usually going to be asked the sum of or something like that, okay? And you'll see in the examples we do. Now there's a formula that they explain how they get it here, and I'm not going to spend time going through it because we don't need to know that. There's no proof of it that we need to know. It's just this formula down here, which is in your maths tables on page 22. So that's the formula we've been using, and that's the one that we're going to be using for series. A is still the first term and D is still the common difference, and that's what we're going to be using. So I'm going to go through 3 examples, the 2 in the book, but I'm going to do one before that because I think they start off a little high. I'm going to start off with a very simplified version and show you the difference between a sequence and a series, okay? And then we'll go through these 2. Right, so the first one is, I'll turn off that light and zoom out. Right. So I've simplified this down very simply. You can see now it's a series because it has a plus in between them. But when it says Sn, or it might say the sum, so it wants the rule, and then it wants the 20th, the sum of that means the sum of the first 20 terms. Remember when we said T20, that means the 20th term. S20 means the sum of the first 20 terms. Tn was the nth term. Sn is the that we can find the sum of any amount of terms. Alright, so what we do is we still need A. So we look for the first term and the common difference. This is arithmetic. It's going up by the same amount. It's plus 2. A is 3. D is 2. Plus 2. Okay, we go to our maths tables and we know that Sn is equal to n over 2 times 2a plus n minus 1 d. Now, if you were just asking this question S20, you could sub in your A and your 3 now and your 20. But what they want to do is they want to sub in just the 3 and the 2, just so you have an Sn for any number. So we have n over 2. I'm not going to sub in the 20 just yet, just to get the Sn, is 2 times A, which is 3, plus n minus 1 times 2. I'm going to multiply that bracket out again. N over 2 times 6 plus 2n minus 2, and I'm going to leave that as n over 2 times 2n plus 4. That is Sn, that is the rule. Now again, I could have substituted in 20 to get 20, but they usually want to simplify it. If they ask for Sn, it's simplified like this. And you could multiply out that bracket to get, well actually this one does simplify down, because if I multiply out that bracket, I'm going to get 2n squared over 2, which is just n squared, and n times 4 is 4n divided by 2 is plus 2n. So this one simplifies down nicely because the 2 goes into each of these. If it didn't go into each of these nicely, I wouldn't bother multiplying the brackets, but it has there. And now I found Sn. So that's a term that will give me any number. So if I want to find the sum of the first 10 terms, I'd substitute in 10. But it wants me to substitute in. So the second part is S of 20. S of 20, I just substitute in 20 squared plus 2 times 20, which is 400, plus 40, which is 440. And again, if I wanted the 50th, the sum of the first 50 terms, I'd substitute in 50. I'd substitute in 100 if I wanted the sum of the first 100 terms. Okay, so again, that's an example that's not in your book, but there is questions like that in the book, and that's the start of it. So if they ask for Sn, just substitute in your A and your D and simplify it down. And if they ask for S20 or S50 or S anything, you just substitute that into your term. But if they just asked for this at the start, you could have substituted everything in here and saved getting to this, and you would have been able to just work with numbers. So, but that's the first example. The reason I didn't do this one first, because I think this one's a bit trickier. Well, it is a bit trickier, okay? It says find the sum of the series. And the difference between this question and the last question, look, it gives us the final term. 144 is the last term in this series. So in order to find the sum of the series, we need to know how many terms are in this. Now you could count up, okay, and I'm sure somebody's we know it's going up. We know A is what? 4, and D is, the common difference is plus 7 plus 7 plus 7 is 7. Now, we could count up in sevens, the next one 32, 39, and see how much to 144. But what happens if this was 1,000 and something? So to find out how many terms are in this sequence, or series, sorry, how many terms in series, we're going to go back and use our Tn, because we know the last term is 144. So do you remember we had a question in the last section said how many terms are in the sequence that has 144 matchsticks, or this, how many patterns are in. So what we're going to do is we're going to use our Tn formula, and the reason we're going to use that is because we know the last term. Okay, so we need to know how many terms are in this altogether. So Tn is equal to 4 plus n minus 1 times d is 7, and I know the last term is what? 144. So when I multiply that out, I get 7n minus 7, 4 minus 7 is minus 3, equals 144. So 7n is equal to 147. So n is equal to 147 divided by 7, which is 21. So there are 21 terms in this series. So what I'm actually going to find is S21. Now if I'd given you this as the first example, I think this would be way too difficult. So I think the book is incorrect in starting off with this. You've never seen series before. So what we're going to try and find is S21. So I write down the formula for the series because it does ask us for the sum. So the sum of the series, so Sn is equal to n over 2 times 2a plus n minus 1d. And this is where it comes into play. Remember in the last one, we had to go and we had to find Sn. It doesn't actually ask us to find Sn. We've got which one we want, S21, so you can substitute everything in straight away. So 21 over 2 equals 2 times 4 plus 21 minus 1 times d, which is 7. That equals 21 over 2 times 8 plus 20, because that's 21 times 7 is 140. And we end up with 21 over 2 times 148. And the 2 will divide into 148 with 21, but that equals 1554. So it ends up 1554. Just check that, how you can do that in your calculator. 21 times 148 divided by 2. Okay, so that one was trickier. You had to know that we needed to know how many terms are in the sequence, and to find out how many terms are in the sequence, we know the last term, so we used our old rule to find how many terms, 21 terms, and then we found the sum of the first 21 terms. Okay, I'm going to do one more example for you. Okay, this question's thrown me a few times because of the wording of it. I remember doing this last year actually. And it says, to celebrate the birth of his niece, an uncle offers an open savings account with a positive 50 euro. So he goes to a savings account and puts in 50 euro. He also offers every year, so on our first birthday, second birthday, he'll put in 10 euro more. So on our first birthday, he'll put in 60. On our second birthday, he'll put in 70, 80, and so on, until his reaches 21 years of age. So on 21, he's going to give her the present. Now, this question, the way they do it out, and I'm just going to follow the way you do it, so when you look back at it, it's the same. I'm presuming he doesn't put in anything on her 21st birthday. He withdraws it and gives it to her on her 21st birthday. So he puts in at 0, and then every year. So there's 21 investments he put in, because on her birth date, and then on her first, second, third, fourth, all the way up to 20. That's 21 investment, and that's where he's getting the sum of the first 21 investments. So if we write out that series, Sn. So we know if we write out this series, A is 50. He starts with 50, and each year that increases by 10. Because if I was to write out that sequence, it would be 50 plus 60 plus 70 plus 8, etc. All the way up till they're 20, and then on the 21st birthday takes it out. That's the way the book has read the question, so I'm going to stick with that. I'd say there's argument to say that there's actually 22 deposits, but I don't know whether he puts in another bit of money on her a bit of money on her 21st and then withdraws it. So we're just going to take it as the book does it. So A is 50 and D. Find Sn. So remember, Sn is equal to n over 2 times 2a plus n minus 1d. N over 2 times 2 times 50 plus n minus 1 times 10. I'm just going to scribble this out, equals n over 2, 100 plus 10n minus 10 when I multiply out that bracket, so it's n over 2 times 100, 10n minus 90. And can you see, they don't multiply that out anymore, they leave it like that, and that's fine, where you could multiply it out and have 5n squared minus 45n if you multiply, but it doesn't make a difference, okay? You get to that stage, you get full marks. And now S21, because there's 21 installments they're saying, so by going by that, they're not putting any extra money in on the actual 21st birthday, they're taking it in. So there's 21 installments. So it's 21 over 2 times 10 times 21 minus 90 equals 3150. Okay, if you type that into your calculator, that's going to be where 210 minus 90 is 120 times 21 divided by 2. Again, I'm not going to go through the working out of that, you can do that in your calculator. Okay, so there's the first two examples plus a previous example. If you take all those down, I'll give you some questions. Any questions, please ask. We're going to be doing this for the next couple of days.